Okay, and then share screen. Today we will go over the last discussion about linked list. So what today we will mainly focused is the linked list class from the collection. Okay, so that's what just like a stack and a queue. Hold on, the pen not working. Okay, so this linked list, okay, not our own implementation of the linked list. And this version of linked list is more close to the linked list that we discussed yesterday, okay, for this linked list. And let's take a quick look how this going to work for the linked list. So for this example, I have 3 files. If you take a look at my project, I have 3 files. So it's similar as example 2, I believe. So we also have that clone class defined and have the car class defined. So we can do a quick review of those 2 classes. So it's the clone is an interface. I'm sorry, it's an interface. And then that car class, we implement the clonable interface, okay? And all the car class is also quite a simple one. And the focus is going to be this linked list. So this linked list is from the collection library, okay? So let's see. Then the same thing, it's going to be, it's also generic one, okay, in the collection library. And the linked list, if we want to use just like a stack and a queue, is it? And you just go, and the linked list from collection library, it's a concrete class, okay, not like a queue. You remember the queue in the library, it's an interface, okay. So this linked list is a concrete class, and if you want to use it, then you need to give the specific data type. In this case, we are going to create a linked list of the cars. And then just as usual, you call new linked list, initialize a linked list. And then we are going to create each individual car, is it? And then over here is you just add. So this add in the linked list library is similar as what we discussed yesterday. It's just add at back. At back, okay. And then it also support if you want to take a look what's in the linked list, is it? And so basically over here, the print lines also support the toString implicitly. And then we can keep adding new car, is it? So over here we add 5 new car, and then we check what's in the car. So nothing new here, pretty straightforward. And what the next one shows is over here. For the linked list in the library. And over here, this statement we call the clone, okay? But here, be careful. This clone is not a deep clone. So collections linked list is just a shallow copy. So the difference between the deep copy and the shallow copy is, so this is that linked list, is it? In this case, it's a list of cars. This linked list, is it? And each of the information part is a car, okay? So over here, it's a car. Is it? It has a bunch of cars. And then this list of car 2. List of cars 2, is it? And even though you call the clone, but over here it says it's a shallow copy, is it? So basically it also points to that. It's just another name. So just be careful if you change anything of the list of cars node, it will also impact list of cars. So that's what the deep shallow copy means. Okay. So be careful. And I remember our version of the clone is a deep copy. Okay, if you want to do deep copy, then you need to do node by node copy. So the deep copy one. So this is the what we just discussed is the shallow copy, is a list of cars. Okay, point to this list. If you want to do deep copy, remember we discussed, then you need to do node by node copy. Is it? So you need to know, and not just node by node, and we also needed to be careful, is it? So over here, it's a car object. Is a car object, and you don't want the second linked list car also point to the first linked list car. So you also want this is a copy, okay, copy of car object. Okay, so it's another car. It's just have exactly the same stuff defined of the instance variable, is it? So this then, in this case, is going to be a real deep copy. Not just the list itself, okay, it's also the car, okay, itself as a copy. And because otherwise, if car doesn't have the clonable, okay, so in our case, the car has a deep copy of the clone, is it? Deep copy of the clone method, is it? So why it's this comes? Hold on, I don't know why something mess up my computer here. Hold on, let me stop sharing for a little bit. There's something mess up over there. Okay, and then what I just explained is a deep copy of the linked list. So we also needed to be careful. The scenario is that's why over here that car class is it has a deep copy of clone method, is it? Because otherwise you may have a linked list created and you think it's a deep copy of the linked list. But if over here it's not its own copy, if it's just a reference to the other linked lists car object, then that's not a real deep copy, okay? So we needed to be careful when we have the data structure, and the data structure type is also a class type, is it in this case? And this is mutable, is it? Not like integer and string, we don't need to worry because they are immutable, okay? And over here, it's mutable class, so you need to be careful about the real deep copy. Okay, real deep copy. Okay, so that's just some side notes about the clone. In linked list, okay, just keep that in mind, it's a shallow copy. And then next, it also has that contains method as what we discussed yesterday. It's just check if a certain item is inside that linked list. If it is, you can remove it, is it? And later on, after we run our program, you will see it can be removed. And it also supports that get function. As yesterday, we also discussed our own version, linked list. We also have that get function. That in this case, you specify. So over here, that's the index. That's the index, is it? And then you can do retrieving of the certain item. And what the next part show in the linked list that provided by the library, it also support iterator. Okay, iterable interface. So that's why over here you can also call the iterator method to get the first, basically it will lead you to the first node of the linked list, okay? And over here, let's see, then you can use the iterator to do the loop, okay? And over here, we call this an external iterator to do the loop. So you can use the has next and the next, is it? To get the next item. And also be careful, the next item in the library, what it returns is an object. That's why over here, you our node's information part is a car. So over here, you cast it, okay? Cast it to a car. And then you also want to, over here, we want to check. We want to try to find some certain item, okay? And here we want to find the car 3, is it? And if you find it, you're going to remove it from the list. But over here, what I'm trying to explain is, over here, we can also see why sometimes we need the iterator. Okay, we need the iterator. And over here, the case is after you call the remove, okay, this loop won't be terminated. It will continue. So it will continue check has next and next. It won't be stopped, okay? So if you have this, so that's why sometimes we do need the iterator, iterable interface, is it? On one hand, it supports that for each loop, is it? So that type X and collection. On one hand, it supports this for each loop. And if we previously emphasize, if you don't have iterable interface, then basically you cannot do this for each loop. So it supports for each loop. And on the other hand, the iterator itself, you see, it provides some nice things for you to handle specific item within the linked list. So over here, you can do like remove and insert, okay? And it will still let you continue your loop, is it? So over here, suppose, okay, this is car 3, is it? You remove it, is it? But because the iterator, over here, we keep track of the iterator, so it won't just stop your loop. So it will bring you to the next node so that you can continue to finishing your loop. And then let's see, over here, let's see this regular for each loop, okay? And if we take a look at this regular for each loop, and as I explained before, because it's using the external iterator, okay, even though we didn't explicitly see it called iterator, but implicitly it uses the iterator. And this for each loop, is it? And if over here you also say, okay, if it has the car 3, is it? And you remove, is it? And we will see, if we do this remove, and basically the loop will be terminated. So in this case, and once you find it, is it you said, okay, I call remove, but the loop will be terminated. The loop won't continue. Okay, and we will see the running result after I finish explain. So over here, it explains the difference between you use iterator to do the loop versus you use this kind of for each loop, and especially the other kind of for loop, is it? Especially if you do for integer I from 0, I then less than like the list of cars. you call the data size, and then I++. Oh, that's just, I always got it back. And if you do this kind of definite loop, is it? And because over here you call list of cars the size, but just think about you call remove, is it? And the size change. So that is not allowed, is it? So that's going to be invalid. Okay, so we cannot do that. Okay, and so over here, just be careful, okay, when you have loop with list and then you do insert and remove, then you need to be careful. And there are some other side notes, and it's quite interesting. We call it using internal iterator, okay. And basically over here, it's after Java 8, it introduced, we call it functional programming, okay. So it introduced stream functionality. It's quite succinct for the coding. So you can write very concise code. And it's a recent number of years, it's more trendy to write very concise code. So let's take a look. What does that mean? Okay. So therefore, the linked list in the collection, okay, it also has a function called string. Then you can convert this to the string. And then with the stream over here, what it says is basically just Java utility does stream. What it does is that it contains classes for processing sequence of items. Okay, for sequence of items. And the stream is just some sequence of items and the concept. And so it deals with the sequence of items as kind of a stream, is it? And the stream concept in CS, we have like IO stream. And previously, I remember when we discussed file input, is it file output, we discussed IO stream. And also standard, so in this regard, it has two kind of stream, is it standard IO stream, is it? That's just a keyboard stuff, is it, or display the monitor? Is it like our system.out? Is it a system.in? Is it a print line? Is it just on your screen? Is it? So that's, we call it a standard IO. And there is also file IO. Is it? So that's IO stream. And another kind of stream is over networking stream or internet stream. Is it? And why we call it a stream is because it's kind of, you can think about it as some pipe. Is a pipe and it's flow in and flow out. Okay, so that's why. So this we call it networking IO. Is it? Or in, so the networking IO. And over here, so over here, we also, oh, not IO, the networking stream, okay. And over here, we call the stream. So basically, this is kind of logical, is it? So what the concept is, it's kind of, you can convert the sequence of items, is it? And through some kind of pipe, is it? And then to get it to stream. So it's kind of, then we can, treat it as a concept also like the standard IO or networking the stream IO. So that's kind of, and with this, after you convert it to sequence of items, then there are, it also supports a lot of method operations. So we can do some aggregation operations, okay. And because for Java, it's also in the real world application, it also involves a lot of parallel processing, is it? And so that's why if we converted it to stream, then we can do a lot of parallel processing, but this is some extra topic. Anyway, over here, what the next shows, it's also, you see, it's called for each, is it? But this for each is a method, okay, be careful. This for each is a method. And then within this for each, this, I believe you may still remember, is it what we learned? So within this for each, what you can do is what? This is our lambda expression, is it? So you basically use the lambda expression. What we did is, okay, so for each single element from that sequence, is it? I'm going to do what? I'm just going to do the output, is it? So that's what this part means. And why it's working, that's because it uses the internal iterator, okay? And then let's take a look more about that. It's quite useful. And then in this case, why we see, you see this code is very concise, is it? With a single statement, is it? You do loop, is it? And you also do some task you can specify, is it? So any kind of task you can specify. And the next, let's see, it do more of the work, is it? So after you convert to string, you can also call filter. Okay, so you can put some condition to filter out some items from your collection, is it? And what over here, what it does is, okay, try to select what? Select car 5. Okay, I'm going just to select car 5. So if it is car 5, then I'm going to store it somewhere, is it? So that's what this filter method does. Okay, and after this filter, what it does next, then it call for each method again, is it? Call for each method. What does the for each does? The for each then does what? Oh, it does some output, is it? But this output, you see, oh, I'm going to do what? Also convert it to uppercase, is it? So if you take a look, you will find over here, I just use this single statement. This is just single, but it does a number of tasks, is it? Does filtering work? Regularly, if you do filter, you need a loop, is it? And then next, it needs another loop, is it? No, but here we don't have any loop, is it? We just keep calling those methods, and it take care of the looping, is it? And that's because it has internal iterator, it's supported, okay? So this kind of coding is very efficient, it's very concise, okay? So that's just some side notes. And then next, let's do this. So what I'm going to do, I'm going to comment out this part. Within the iterator loop, I'm going to comment out that remove, okay? Then I'm going to add this for each loop, they are going to do remove. So let's see if the loop is terminated, okay? So here just try to show. And the list, we have default first, then we add car 1, 2, 3, 4, 5, is that? And did we, okay, then we remove car 4, okay, remove car 4. And here I'm trying to remove car 3 also, is it? And then we will see if it's a loop through the end of the iteration. Okay, so initially we only have a single car, is it? Then we add 5 more car, is it? And this second list, okay, it's basically a shallow copy of the previous list. And then I remember we remove car 4, is it? So if you take a look, you will find car 4 is not there anymore, is it? And you can get the first car, is it? And then over here, okay, over here is we remove car 4, is it? After we remove car 4, we have the default car 1, car 2, car 3, car 5, is it? So that using that external iterator explicitly loop, is it? So it loops through the end of the list. But if you take a look at the for each loop, this for each loop, is it? It find the car, is it? Find the car and remove it. But if we take a close look, did you see? It's a stop. The car 5, is it? Didn't loop through the end, is it? So the loop is terminated, is it? Yeah, so over here it shows if you use that regular for each loop, if you do some removing or inserting, then it will basically destroy your loop, is it? And what the next one shows just that regular, the other for each method to do the loop, is it? And the last part is just you want to find that specific car, is it? And we convert it to uppercase, okay, using the string concept. Okay, so that's the, let's go back to our, so over here, what we discussed is we use the linked list from the collection library, okay. So we learned the linked list, and so far we already learned 3 new data structure, okay. Stack. We learned stack, and we learned queue, and we also learned linked list. And previously, we also discussed array list. Is it array list? And another one is you can use it to store number of items is array. So all of them, they can be used to store number of collections, ordered collection of items. And the difference among them is stack is what? Is LIFO. Is it LIFO? And we also discussed a number of applications pretty good for stack. And the queue is FIFO, is it? First in, first out. And we also discussed a certain number of applications, and it's good you use queue, is it? And based on queue, I remember in your assignment, we also learned the concept of DAC. Is it? DAC is a double-ended queue. Ended queue. Okay, and sometimes it's good to use DAC. And we learn linked list, is it? And what's the major difference, then you may ask, between linked list and array or array list? Is it linked list, then the case is, so if you have a lot of insert and remove, is it in the middle? Not absolute middle. Okay, so here is all we call it anywhere. Anywhere. Okay, in a collection of items, then it's good you use a linked list. That's the advantage. Okay, so a lot of insert or remove operation previously at the beginning of the linked list, I explained why, is it? And the array list, then what is good is if you have numerous access anywhere. Okay, it's just access. It's kind of the retrieving, okay, the get operation. Is it if you want to do that, then it's good you use array list, okay, because array list, the key part is array, okay, not like a linked list. The key point is linked, is it? So that's the major difference. So whenever you want to use the data structure, then make sure to identify which is the most appropriate data structure. Okay, so that's the general concept about the linked list, and we finish the linked list discussion. And the second part for today's discussion is going to be the exam review. Okay, exam review, and we will have 5 questions, and you can go to our course website to open that study guide. And the first 2 questions, and I don't think I needed to go over it, okay, because it's pretty straightforward. You can try to run it in a program to see how it works versus you hand trace the running result, okay. And the next, let's see, the third question I remember, it's about a recursive function, okay, recursive function. So for recursive function, and what over here it ask you to do the sum of the array, and we know the sum of array more efficient way is you do the iterative way, okay. So this more efficient should be iterative implementation. But over here we discuss the recursive ways. We just try to see how recursive works, okay. And anyway, so this is sum of the array. So you have the array as parameter, is it? And then to specify where you are going to start to do the summation of the array and where you are going to stop the sum of the array. You have the both index, okay, both index. So the concept over here, if you take a look, my code, it's quite simple, is it? But the concept is like this. So suppose over here, we have an array, is it? Have an array, and over here I have 100, 200, 300 something, is it? 400, is it? So this is our array A, is it? And it's identify the index first. So first it's going to be sub-0, is it? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, is it? So this is 8. And this is going to be our last index, okay? And how we do the recursive way implementation of the sum of the array, is it? So the idea is, because when you do sum, it's always you keep adding, is it? You keep adding each of it, is it? And then if we naturally think is, if you advance the first index, is it? Advance this index, is it? Then it's going to work, is it? It's going to work. So over here, what we did is, okay, you get the first item, is it? And then you add it, then you keep call this method itself again, is it? But you're going to use a recursive case, is it? So here is a recursive case. Recursive case, and you're going to change the index. Just be careful, okay, here you cannot just plug in first. If you plug in first, then this program will never end, is it? So you need to change this parameter, okay? And over here, we increment it, is it? The index is going to keep changing from 0, then to 1, then to 2, then to 3. Is it going to keep moving, is it? But the last index, you don't need to change. Or you can do the other way. You add from last, is it? Then last going to decrement, is it? And when you stop, okay, of course, when the first go beyond, is it? Then you stop, is it? And what do you return? You return 0, is it? You cannot keep adding, is it? So this is a stopping case. Okay, so whenever you write a recursive function, always remember you need to provide these two cases, stopping case and the recursive case. And for recursive case, you need to change the parameter, okay, so that it will bring the recursive case to the stopping case. Otherwise, your recursive function will never stop, is it? So that's the major concept. And also, because based on the submission of the homework and the past the classes experiences, just remember, whenever you write a recursive function, you need to achieve recursion, through what? Through reducing the case. Okay, through reducing case. So over here, we reducing the case is we increment our first index, is it? So you keep moving the first item. Okay, so not use loop. Do not use loop to achieve, okay? Because if you use loop, loop is what? Is iterative. It's not recursive, okay? It's a complete different concept, okay? So keep that in mind. Generally speaking, the general rule, rarely, very, very rarely, you will see a recursive function to have a loop, okay? So whenever you write a recursive method and you say, oh, I'm going to use, that's not a recursive function, okay? So that's this first question. Okay, and then I just create an array and try to call that recursive function, and it did work, okay. And for the second programming question, it's regarding you needed to write a method. I remember. So a general method, okay, it's not belong to some class, but of course over here to still belong to our driver's class, okay. So what over here you try to do is you have a stack, is it? And you have some items, is it? And you're going to remove this item because we call it 100, 200, 300, 400, 500. Okay, what it asks you to is you remove certain item. Over here is 300. After you remove it, then your stack still going to have 100, 200, then 400, 500. So of the remaining items in the stack should be still inside the stack as the same old order, okay? So this is what this question asks you to do. And over here, I try to simplify my work. So I use the collections stack, but be careful, okay, in your exam, do not use a stack from collection. Okay, so you need to use stack provided. Okay, use a provided stack as our study guide given. You need to use that stack. So over here, then how do we achieve that remove item go? Is it? So over here, what I did is I use an array list. Okay, because I needed to keep track. Is it so 100, 200, 300, 400, and 500? Is it I want to remove the 300? Okay, so if you didn't find the item, so if the item is not 300, what you're going to do is you have that array list. Is it 100, 200, 400, and 500, is it? And then this stack is going to be empty, is it? After you finish this loop, is it? You find it and then you pop the top item. until you finish the stack, is it? And what next you need to do is what? You need to, oh, I don't need this one. Okay, you need to get off the item back to the stack, is it? Because over here I use array list, is it? So I can back the over here. Oh, I'm sorry, it should be 500 because I pop 500, then 400, and then 200, and then 100. Okay, so this is our array list, is it? So this is going to be the kind of like sub-zero location. Okay, and because I have this, is this array list to store whatever inside the stack in the reverse order, is it? So that's why if I want to push it back to my original stack, is it? So I'm going to get to the last one first. So get to 100 first, is it? And then get to 200, and then 400, and 500, is it? So that's how what I did over here, okay? Then let's take a look at the last one. What the last one is, you're going to merge two Q, okay? And then you're going to return that merged Q. So how do we do this? So this is kind of, okay, we have Q1. Q1, suppose you have 100, 200, 300, 400 something, is it? And you have another Q2, is it? And Q2 is negative 100, negative 200 something, is it? And what over here, also remember in exam, don't use the collection, use what I provided Q, okay? And here I try to simplify my work to illustration, okay? And so over here, I create a Q, that of course, because you need to return this Q, so you need a Q object to be created, okay? And in collection, because the Q is an interface, so we use a linked list to represent the Q. And then what over here we did is we use a while loop to loop through both Q, is it? And use all condition, is it? So if it's not empty, so then this is going to be my return Q, is it? So I'm going to get 100 here, is it? And next, if the second Q is not empty, then I'm going to get negative 100 here, is it? And I'm going to keep doing this, is it? Then 200, oh, then negative 200, is it? And you keep doing this. And then you will get this new Q, is it? After you get it, then you can return it, is it? So that's how this method, what I did, okay? And we can try to run it to verify. Yeah, if you run it and verify, you will see it did work. Okay, so that's the review for the for tomorrow's exam. And do you have any questions? So any questions?
So we need to either download either your Java files for the stack, or we need to copy it for our own for the exam.
I remember I posted the code on the study guide, so you can find both stack and Q class at the back of our study guide. So you can copy it. Basically, it's just for your reference, because in our exam, you don't need to completely recopy the both class. You just need to know which method in those two class you're going to use. Does that make sense? Just like you basically need to get familiar with like push, that pop, top, empty. I don't remember exactly the method as, and I don't remember other methods. So kind of majority of those methods for stack. And for Q, it's like a in Q method, a DQ method, and the front method is it, and empty, and maybe some more. Okay, for Q. So you basically just need to know those methods and how to use those methods for those questions. Does that make sense? So any other questions? Any other questions? We needed to get it clear for tomorrow's exam. Or everything is good?
So tomorrow's exam